I will try to say more like that. So you cannot call new. It's not a constructor. You cannot call new. You cannot do new my generator. You just call it as a function. Invoke it as a function. Some of the JavaScript interpreters, engines, they raise an error, type error. They will say my generator is not a constructor. Others won't. So be careful. Just remember no new keyword before the generator. Another rule, a function generator must have at least one yield keyword. You cannot have a function with the asterisk, with the star, without having a yield within it. It will complain. And the other way around, actually. You cannot have a function without the star, without the asterisk, with a yield keyword inside. Yield is our door, so we enter the function generate. So you cannot have, they go together. If you put the asterisk, you have to have at least one yield keyword. So this is bad code. This doesn't work. The yield keyword, I just said that, but as another example, you cannot have the yield within a non-generator scope. So in this case, this is a good example with the asterisk attached to the function keyword. In this case, it won't work because yield is within the scope of for each. It's not within my generator. So, sorry, in the back is readable enough? Do you want to? Okay. So this will work because yield is within the scope of the generator. This one. Let's see how the generator is made, how and what its nature. Here you see how the generator has to be invoked. So no constructor keyword, no new keyword. And calling this function, the generator function, will return an object, a generator object. And that is a very specific object in JavaScript. And it implements three interfaces: iterator result, iterable, and iterator. And we will see that shortly. What does that mean? Iterable. What does that mean is that a generator can be iterated. So if I destruct it with ES6 spread operator, like that, the result will be an array, because I destruct within the array. The result will be, that's our example. We have two yield keywords. We're going to see it better in a moment, how the yield keywords work together. But for now, we just need to understand how this interface works. So destructing a generator gives you back iterable values, iterated values. So in this case, the first one, the second one in an array, like that. We can also destruct it this way. So x will equal to the first yield value, and y will be the second one. So first interface is iterable. Yeah, also this way you can iterate through a generator. So console log will log you out the values of the yields. Iterator interface. That means that the generator has breaking stuff here. Implements a next method on it, and it might or it might not return a value. So in this case, for example, we have a return. You cannot have it if you want, based on your need. We will see why when you call on the generator the next method, in the next slide we will see why we get back an object like this, because it implements the third interface, which is iterative result, which is that object. But basically, you have this generator, you invoke it like that. This guy is being assigned by the equal with the generator object, and if you do next on it, you'll get back the values 32, done false, we'll see why. Another next yield some text, you'll get back that value. And the third one returns done false, true, because there's no more, there's nothing to iterate. And the very last next, which is basically when it's done iterating, that is when you get back the return value. So with the very last one, we will get back other text. Yeah, and here is the reason why we get back that object with value and done, because it implements that iterator. But we will see that very soon, how everything works. This is the end of the presentation. It's very short, but I like to see things happening, and I will just go and show some stuff in practice. Sorry, can I stay with this chat? So what I want to do, I want to start from a simple example and start making experiments so you guys can understand how it works. So let's say function my generator.
Can you zoom in a little bit, please?
Yeah, now it's difficult to read.
Yeah, sure.
So far, that's fine.
Is that better?
Yeah.
Let me spell generator. Let's be picky. So let's try yield 4, because we need to see and to understand what that means, what the yield does. I don't know, John. Yield. High. And yield, let's say 1. Okay. Here I have my generator. That's how I invoke it. And now if I call next on my generator, let's put this in a variable so we can log it out. Let's do this for a couple of times. So if I run this, I get back 3 times an object which we saw the structure. It's because of the iterator result interface.
Can you zoom in there as well? Go solo.
Yeah. Better?
A little bit more maybe.
Like that?
Yes.
Okay, so let's try to understand what happens here. I invoke my generator. I call next on it the first time. What happens is that within the generator, the interpreter starts interpreting the code. So it goes to the first yield. And this is the first time that we pause the function. To resume, we need to call next again. And so on. When you call next, it goes to the next yield. When you call next again, it goes to the next yield, and so on. Let's add one more because we have 4 times yield. Actually, let's add a few more and see what happens. And if I execute that, and I see the 5th one is done, and after that, no matter what you call, what you do, you'll always get done back because it's done. With the generator, it's finished. So one nice thing about generators is that you can pass in a value, and we will see what happens with the yield keyword in that case. So let's say a string. Here we will say Tony, world, and let's see what happens. What you can notice is that you get back, through that object, you get back the value that that you have on the right side of the yield. But there's an interesting thing, which we will see right now, adding some console logs. First yield. I know it might seem a little bit confusing. It is confusing. The generators are very confusing, and they have, I would say, unexpected behavior. But it will make sense very shortly. I will just do that even though it's first yield everywhere. So, execute again. What happens here? The cycle is the first next, the first time that you call next, nothing happens. The first next doesn't accept any argument. Anything you pass just gets lost. Some JavaScript interpreters, they even raise an error if you pass something to the first next. So the first next is just to get the generator starting, to start iterating through the yield keywords. So when you call the first next, it gets to the first time that I pause the function. And what happens? I get back the value that I have on the right side. When I call next, it returns back the value that I have here on the right side. Second time, I pass in a value. This time it accepts a value, any value. And on the right side I have John, which is returned back through the object, as we can see here. But it gets me back whatever was there before. So I get back John, which is on the right side of the yield, but the yield keyword itself becomes a placeholder, becomes a variable basically. So yield now is equal to high. So first yield in this case is no, it's actually this case because the first yield is here with the first next we got there. Now this first yield is equal to whatever we passed through the next method. And it contains that value that you pass in, and it waits. It's there. It's waiting for the next method called. I call next again, passing in a new value. I get back John, as you guys see here, and then yield equals to Tony. So it's the next value that I pass in. And so on with the rest of them. So what's here to remember is that the first next doesn't do anything. It just starts the generator. From the second next on, you just pass in something if you want. That will be assigned to the yield, and you get back whatever is on the right side of the yield. Oh, sorry. Let's see how it behaves when you have a return. And we will keep evolving the example, so we will get eventually to the reason why this generator exists and why the yield exists. So let's evolve it like that. Return last thing. Execute again. Yeah, we do need this one. No, this one is not needed because it's already done. So it does not. No, it's the other one. So what happens here? We already saw the behavior of yield and next called on the generator. It just go from a yield to another, and return happens as the last thing. So when done goes true, and the generator is done, that's it, doesn't have anything more to do, then that is the time that you get back the value that it returns. What's important to add here is that if I do this for x of my generator, and I console x. Let's comment this out for a second. What's important to notice is that when you iterate through the generator, it will not return that last value. So that is returned only when you call next on it, not when you iterate with the for, with the destructor on the generator. So in this case, we will not get back last thing as the last call. So that's important to remember as a behavior. It's very abstract stuff, but it will start making sense. So let's get a little bit more fancy and start adding some crazy stuff. Just like that. Okay, let's see what happens. 1, 2, 3. Only one more. And let's just what happens here? We have yield 3 times, and it just behaves as you would have anything else on the right side. So the interpreter starts from this. The first next gets there, and it's pausing the generator. You call next again. You pass in the high string. Whatever was here, which was undefined, because we didn't pass anything, because the first next doesn't accept anything. This will be undefined, because whatever was here gets assigned to that. We call the second next. We get back undefined, but this now will be equal to high, because we pass it in. It's a placeholder.
Which one?
Sorry?
Which one?
All of them are placeholders. So basically,
Yeah, but which one is high?
the second one.
Okay, and the first one is gonna stay empty?
The first one is gonna get excluded because it's already passed. So on the first call, you get here, but it's undefined. The second call, you pass in hi to this guy, you get back undefined to that object that it returns. So now this is equal to hi, and it returns back undefined. Let's change this because it's hi world blah blah. So yeah, this is the result. First yield returns back undefined because the first next doesn't accept anything.
Can I ask you to zoom it a bit?
Yeah,
and,
sure. Which part?
expand? Like the console output?
Better?
A bit more?
Like that?
Yeah.
So, first yield, we get there and pause it through the first next, right? And it's there, it's waiting. We call the first next, we pass in hi, this guy is equal to hi now. No, sorry, this guy is equal to hi because it's the second time that we are iterating. And we get back whatever was on the right side of the yield. So on the right side we had another yield, but it was equal to undefined. So we get back that. That's why we have undefined here.
Can I ask you one thing?
Sure.
What happened to the console logger which is inside the generator? Never gets executed.
Sorry?
It never gets executed.
The console log? Yeah, it's here.
That's actually the one in the bottom, right? No. Is it console log res?
No. The string, the console log res is the object.
Could you delete that console log and rerun it, please?
Sure. We will see that later, what happens there. But for now, I don't get my execute now. So you see there's no blah blah anymore because it was part of that console log. So back to it. Can I scroll? Okay. So second time, this is equal to hi, and it gets back whatever was here. Third time, we get to the third door. Whatever was here gets back, and that was equal to hi, right? And we pass in world. So this guy now equals to string world. When we call next again, this gets assigned, and there's no yield anymore, so it just continues and it finishes the generator. And that's how it returns the last time done, true, and the value on the right side of the return keyword. Does that make sense?
If you put no return, so the last will be just value undefined, right?
Yeah, value undefined and done still true because it's done with the iterating.
Okay.
So let's see it in work. I need a bigger screen here. Okay, it's undefined now. Okay, let's get a little bit more fancier.
Can I just ask a small question? The first yield variable, does the last yield, is that the one which is held as first yield variable, or does, like if you console log first yield right now again, like just leave it and then console log it again? Like what does that variable hold?
This one? You want to console log this?
Yeah, so that holds blah blah then, right?
Yeah, because we get there the third time.
And the other yields, they just they get stored.
They are
they
previous
exist
stuff.
as long as the function.
They are previous stuff because when we re-enter to the yield, we are in that exact point of the function. What's been first you can, well, I'll make an example right now. So let's say A equal to yield, B yield, let's put a 1, B, and let's just get rid of this for now. If I'll do console log here of both of them, what happens is that I don't get anything right away because I'm stopped here, I'm paused here. I call the next, the following next. This one, the value that was here, which was undefined the first time, gets assigned to A, and then I go to the next step. So it's pausing here. I call next again. I get back my V value because it's on the right side, and I pass in world. I call blah blah. I pass in blah blah, but you don't have any anything else to any other yield, so it will just finish. It will be done, and it will console log both of them. Let's see it in practice. So again, hi world comes when I called the third time next, because the first one is not counted. We just start the iteration, we get to the first yield, and then I start passing in world. I call next, this is equal to world, I get back 1. I call next again, and I call blah blah, and this is equal to blah blah. No, this is the third one. We have only 2. So first equal to nothing, undefined because the first doesn't accept anything. Returns back 1 because it's on the right side. Second time I pass in high, and I get back B. But B is now equal to high. And A is equal to, no, A is equal to high, B to world, because let's not count this. That's what we should look at, the second 2, because the first next is just to get here, to start basically the iteration. So that's why when you call, in this case, world for the third time is just continues from here because there's no more yield. Does it make sense? Let's get a little bit more fancier. Let's put some stuff in here, like that. Let's do 1. Hi. World. Who can guess what's gonna happen?
Does it just count the amount of yields in the function and just...
Where is it gonna start from? The answer is the first next get to whatever is the first yield, but on the right side of the first yield we have other yields. So this is actually not the first. The first is inside the array. And then the second next, they are actually equal, high 2. So we can see the difference. World 2. 4. So the first one is this. That is the first that gets evaluated. Second one, third one, and then fourth one. And then when you call next for the fifth time -1 because the first next doesn't do anything. Then what happens, all this array with whatever it's inside, it gets assigned here. Actually, you get it back through the next method. And you assign to this guy whatever you pass in through the fifth next. So if we let's get rid of this one and just console log A. So my guess is that it will return back an array which contains let's say on the strings, which contains, well, that actually it's a good example because we don't care what's there. We don't care that there's a number and within the same array also a string. We care what we pass in. We pass only strings. That's what we care about because that will be the final result within the array. So my guess is that the array will contain hi2, world2, world3, and it will be, we don't need this guy. Let's try it without that first. There we go. Hi2, world2, world3. We got back that, but what's gonna console log here now? Who can guess? The array? No, because the array we get it back through the next method. We're gonna assign to A whatever we pass in the fifth time. So with the fifth time, if we pass in this world4, then that is gonna be console log world4. So not the array, because that's what you pass in. Does it make more sense now how it works? You pass in something, you get back the previous thing that was in the right side. It's pretty straightforward. Unless you get even more fancy. So let's do something crazy like this. Yield. This is a string, and then yield here. Looks weird? Yeah, right? But it works because what matters is what you pass in. So let's say my guess is that the first yield evaluated will be this one. So let's say with the first next we just get there. Let's say we pass in a function. Right? Which console logs out parameter. I'm not sure now which one will get evaluated first, but my guess is that it's going to be this one. So the first time we just get there, the second time we pass in a function. So what's going to happen? We will get back this, but yield will be equal to a function. So now the next time we can assign a parameter to the function, and the third time we can execute that function. So let's say let A equal to all that stuff, and now we say hello world here. Okay, and let's see if this works. Skip a few more. invalid JavaScript, but it worked. Because let's try to give it something previous to the function. Because maybe I was wrong. Maybe it evaluates first this guy, and you pass in a function and it gets invalid. So we need this one after the next. Let's try it now. Okay. Let's remove this for now. Okay. Well, let's debug it. What do I get back? First, I get back the string, so I need to pass the function here, that's sure. Then we move this stuff below. We try again, and now it's something worked. So what happens? The first, next, we said we already know, we just needed to get to the first yield, which we know now that is this one on the left, because we received back, this is a string, which is on the right side, right? And it's paused, it's waiting there. What we do next, we call another time next on it, and we pass in a function. So this yield now is equal to a function, to this function. Let me do it again. Third time, we get back 1, because it's on the right side, and we assign world 2 to this yield. So now we have a function that runs with the parameter world 2. And that function just logs out the parameter. That's why we see world 2 here. So as you can see, you can pass in anything. You can pass in an object, you can pass in a class, you can play with it a lot. Okay. Why do we need all this stuff? The function generators, they were created for writing dry, even drier code. So writing asynchronous stuff in a very synchronous, in a synchronous-like syntax. So I will show you a couple of examples. For example, we use this. Does anyone work with the Redux? So you guys know Redux sagas? Okay, that's how you use generators. Redux saga, you can call multiple asynchronous tasks. So you can call an API, and you don't have to chain a lot of then, and then on each one you do validation and stuff. You can just chain everything like this. Yield, this will call the API, it will wait. Yeah, sorry. This doesn't work like that. I'm not actually sure how to zoom here. Huh? No, it didn't work.
Command and scroll up.
Command what?
Scroll up. Command.
Yes.
If you just use the touch screen.
Oh yeah, worked. Cool.
Nice to me.
Too much?
Yeah, perfect.
So we have our API here. We return basically the promise. And the sagas, they are like helpers, which for every promise they will just wait. Because the generator by itself, it doesn't understand the promise. It will not wait for the promise. It will just return the promise. So you need a helper, which when you throw something like an API call on the right side of the yield, you need a helper like this, which will wait for the promise and return it to the yield. And then you got the response, and then you can do other stuff with it. Or if something bad happens, that's why it's in a try-catch block, you can still nest yields and do other stuff. And you can have many API calls like that, and they will all wait for the next one to execute. And you can assign, of course, const response of this one. You'll put it in the second one. You'll get back the third one, pass it into the next one, and so on. So you can chain a lot of stuff and catch everything only once. Because if you have a then chain, then you have to do validation within each one. Is there a response? What to do with it? In this case, if there's an error, you will catch everything in the catch block. So that's basically why the yield and the generators were made. I want to show you another quick thing, how to nest generators. So for example, another generator.
Ask a question.
Yeah, sure.
Why not just use promises?
You can use promises and then nest then, or you can just do it like that and you just have one line. Because if you have a promise,
It doesn't make a big difference, does it?
it's cleaner code.
You can catch errors like that, right?
With promises, I also can catch errors.
Let's make an example then.
For the sake of style.
Let's say you have a promise. Let's say you have a fetch. And you fetch something and you have a then, right? And inside you get a response, which is maybe another call, another promise. Then you have then again. Response. And then you have to do if response here. If has error, I don't know, then do something. Same thing here. And maybe you have another one. Or maybe here you will do this and you will have to call another endpoint. Right? And then you start nesting stuff. And it becomes very more and more confusing, right?
Not always. I can try to keep it flat and just have a catch in the end. The catch that handles all the errors in all steps.
It's up to you if you prefer that. It's an alternative. This is they made it for a cleaner way of writing. You can have in one line and a synchronous task, and you can get back the response as soon as it's done.
I see. But it's difficult for you just given the same example, but with yields, with generators.
This one?
Yeah.
Sure. Let's say we have a generator. Well, I actually have it ready. This is my API call. I just return a promise. And I call it with this helper. This is actually from the helper is from the Redux saga. So what does the helper do is that it waits for the promise. Otherwise, it will return you only the promise, not the response. Okay? And that solves, this call solves the promise and gives you back the response, not the promise itself. That's why you need the helper, because the generator by itself, whatever you pass on the right side, it will just get you back. So you have the response, not the promise. You check the status, you check if there is a response, or if something bad happened, it will catch it here. And on that catch, you can handle it the way you want. You can chain more stuff again. Maybe you need to call another endpoint in here. Different ways of handling. Is that clear?
You have to figure out which, well, let's go ahead.
Yeah, I know it's confusing because this yield keyword, it's kind of like a variable, but because it kind of holds a value, but it's also like a point to re-enter the function to start back from that. So it's a bit confusing, but if you play with it for
now it's clear how yield does work, but need to understand how to replace promises with yields.
Yeah, sure. What you have to keep in mind is that the yield by itself doesn't solve the promise. So if you pass a promise to the yield keyword, it will return you the promise, not the response. So that's why you need a utility for that.
Yeah.
Or for example, there are, let me see.
This is the difference. In a promise chain, you just have then. In the yields, you need to call next somehow on callback.
No, that's the helper. It does.
Yeah,
it does that for you.
Of course. I mean, you can do it manually, or you can use helper, but you still call next on callback.
Like in this, I will show you an example here. Multiple asyncs. I'll succeed with that. What I do here, I use the native fetch. I call this API. I have another one, a small function which returns the promise, another one, and then I put them all together like this. The core routine, that's my helper, which does my next, does the next method, the next call for me. And you have many helpers online. There is Co, and there is Bluebird, which has this core routine utility which you can use. Bluebird, it's for a whole library for managing promises, and you have this utility to do exactly that. You pass in a generator, and it does all the next methods for you. So you just have to take care about what you pass to the yield. So this will fetch the first API, it will wait, I will get my data, I will pass it in to the first, the second, this will wait, and so on. So in one function, in a very clear way, you can chain those asynchronous tasks. So that's the reason basically the generators were invented.
But
Of course.
Can I?
Sure.
Weren't they more invented so any object, which is a list or any kind of data structure, can expose an iterator? So, for example, an array is now so iterable, so you can put it in a for-of loop.
Yeah.
I think the using generators for asynchronous flow is a kind of a bit of a hack, because you still need that third-party library to, like the coroutine, to go through the promises and execute them in a sequence.
It's not a hack, it's just a function that does the next method for you. So to me it doesn't sound like a hack, it's just a utility that just loops whenever the next one is done.
But surely if it was designed for asynchronous control flow, some kind of coroutine library would be built into ES6. It seems a bit... I think so. This is why the async await syntax is coming in the next version.
Yeah. But this will be also part of ES6. It's actually
async await is, I think it's
ES7.
yeah. But I think it pretty much makes this redundant for async control flow. I just think that's useful for people to know.
Async await, it's specifically for calling asynchronous tasks. This one you can play with it. You can find other users using that next.
Yeah, so like I said, if you're writing your own data structure that you want it to be iterable, this is perfect for that. That's why it was designed. but it's not necessarily an asynchronous thing in that context.
They found it useful for the Redux Saga, which is
Yeah.
super used around the world, and they found it useful. And the function generators are the base of Redux Saga, and it works in a really nice way.
Yeah.
And we use them, and it's
I haven't used Redux Saga myself a lot, but I wonder if it can be rewritten using async await in the future. I don't know if that's a thing they're looking at.
I'm pretty sure you can rewrite everything using async await, but this is the way they
do it
went
now,
for
yeah,
it.
because that was the first thing to come up.
Yeah, it's ES6 already, ES7 maybe it's not
Yeah.
done already.
Yeah.
So probably they will change, or they will just stay with this. I wanted to show you another quick example of nesting yield 1, yield 2, yield A, yield my generator. So I'm nesting the generator, and yield B. Okay. Now I'm gonna just run a lot of next methods just to see what happens. So I have 1, 2, 3, 4, 5. I need 6 then. So 1, 2, 3. Okay, we have enough. If I run it now,
Extra quotes.
yeah, sorry. If I run it now, what happens is that it doesn't go inside my.
You should call another generator.
Huh?
Another generator. You should call first another generator. Like constant. Your generator constant.
Can you speak?
Wrong generator. You are just calling wrong generator. You should in the.
Yeah, but I wanna call this one.
No.
Oh yeah. Sorry, my bad.
Sorry, I can't see the line. So just because
You
of.
want me to zoom in?
Because of the
You
water.
guys should tell me. I'm not. Okay, execute now. So what I get back, I get the generator itself, right? So how do I get inside and iterate through that? I have another trick. This. So you use the star for telling this yield that in front of him you basically have another generator, so it should go in and iterate that. So what's gonna happen now? We get back also yield 2, yield 1 and 2. So it goes here, it goes here, and then here, and here. So that's how you nest generators. And that's pretty much it, because I'm pretty sure you're already pretty confused with it, so...
Serghei, just one more question, because
Yeah, sure.
Can you use generators inside while function? While loops?
You can. There are actually some crazy examples when you do while true, which is stupid if you think about regular JavaScript, and inside this while you would put a generator. But of course, let's say we have this utility co, which goes to my generator. And I can yield stuff here, and this will not proceed, will basically proceed until all the yields are iterated. And I don't remember the utilities that you have, they use this trick, and basically the while loop ends when done is true, when the last iteration is happened.
You could do eventually the same by redeclaring a variable from inside, right? The while loop. And then say that
Here? inside. That's what you
well, mean? No, let's say that you declare var done on top, and then inside the while loop you do like so generator next and done.
Yeah, sure. You can do that. So you can run next like in an infinite loop, and when it's done, you just exit it. That's what they do in these utilities actually. So the core utility, they use this trick. They run like in an infinite loop until it's done, and then it exits the while loop. Because it's actually the only way to transpile it right now. Otherwise, how do you know how many yields you have in a generator? You just have to loop again until you see that it's done. That's it. Okay, that's basically it. I hope you guys enjoyed and